Download this code from codegive.com, link in the description below. Cross-origin resource sharing, CORS, in Pega, a detailed tutorial. CORS, cross-origin resource sharing, is a security mechanism implemented by web browsers to control which web pages are allowed to make requests to a different domain than the one which served the web page. It's crucial to understand and configure CORS in Pega environments, especially when integrating with external systems or building modern, API-driven applications. This tutorial will cover 1. Understanding the same origin policy *, the fundamental concept behind CORS. 2. Why CORS is necessary *, the problems it solves and the security implications. 3. How CORS works *, the request-response flow and the role of HTTP headers. 4. CORS configuration in Pega *, methods to enable and configure CORS in Pega platform. 5. Practical examples * code snippets and scenarios demonstrating CORS usage. 6. Debugging CORS issues * techniques to identify and resolve common CORS errors. 7. Advanced CORS concepts * pre-flight requests, credentials, and wildcards. 8. Security best practices * recommendations for secure CORS configuration. 1. Understanding the same origin policy. The same origin policy is the cornerstone of web security. It states that a web page loaded from one origin, domain, protocol, and port, can only access resources from the same origin. This policy is designed to prevent malicious websites from accessing sensitive data from other sites, such as cookies, session tokens, and user data. Origin definition An origin is defined by the combination of protocol HTTP or HTTPS. Domain example.com or 192.168.1.100. Port 80, 443, 8080. Examples http://www.example.com and http://www.example.com/path, same origin, path doesn't matter. http://example.com and https://example.com, different origin, different protocol. http://www.example.com and http://api.example.com, different origin, different domain. http://example.com 8080 and http://example.com 80, different origin, different port. 2. Why CORS is necessary. While the same origin policy is vital for security, it can be restrictive when building modern web applications that need to interact with resources from different domains. Here are some common scenarios where CORS becomes essential. API integrations *, a web application hosted on appexample.com needs to consume data from an API hosted on api.example.com. Content delivery networks, CDN serving static assets, images, scripts, fonts, from a CDN hosted on a different domain. Microservices architecture * web applications composed of multiple services running on different domains. Single page applications, SPAs often make API calls to backend servers hosted on different domains. Without CORS, the browser will block these cross-origin requests, resulting in errors and preventing the application from functioning correctly. CORS provides a controlled mechanism for allowing specific cross-origin requests while maintaining security. 3. How CORS works. CORS extends the same origin policy by allowing servers to specify which origins are permitted to access their resources. This is achieved through the use of HTTP headers in both the request and response. Asterisk request headers, sent by the browser. Asterisk origin asterisk this header is automatically added by the browser to indicate the origin of the request. It contains the protocol, domain, and port of the requesting web page. Example, origin, http://appexample.com. Asterisk response headers, sent by the server. Asterisk access control allow origin asterisk this is the most important CORS header. It specifies the origin, that are allowed to access the resource. It can have the following values. Asterisk allows any origin to access the resource. Use with extreme caution as it effectively disables the same origin policy for that resource generally only suitable for completely public resources. Asterisk http://example.com allows only requests from http://example.com. Asterisk http://example.com http://api.example.com, this is not valid. Access control allow origin must contain a single origin or asterisk. Multiple origins can be achieved through dynamic server-side logic, see later in this tutorial. Asterisk access control allow methods asterisk specifies the HTTP methods, example get, post, put, delete, that are allowed for cross-origin requests. Example, access control allow methods, get, post, put. Asterisk access control allow headers asterisk specifies the HTTP headers that are allowed in the cross-origin request. If a request includes custom headers, other than standard headers like content type, the server must explicitly allow them in this header. Example, access control allow headers, content type, authorization, X custom header. Asterisk access control allow credentials asterisk indicates whether the browser should include credentials, cookies, authorization headers, in cross-origin requests. If set to true, the access control allow origin cannot be asterisk. It must be a specific origin. Example, access control allow credentials, true. Asterisk access control max age asterisk specifies the duration, in seconds, that the browser can cache the pre-flight request, see below. This reduces the number of pre-flight requests sent. Example, access control max age, 3600, 1 hour. Simple versus pre-flight requests. CORS distinguishes between two types of requests. Asterisk simple requests asterisk a simple request meets the following criteria. Asterisk the method is get, head, or post. Asterisk the content type is one of application/xwww former encoded, multi-part/form data, or text/plain. Asterisk no custom request headers are set. For simple requests, the browser sends the request directly with the origin header. The server responds with the appropriate access control allow origin header. If the origin is allowed, the browser processes the response. Otherwise, it blocks the response and generates a CORS error. Asterisk pre-flight requests asterisk a pre-flight request is sent when the request is not considered simple. This typically happens when asterisk the method is not get, head, or post. Asterisk the content type is not one of the allowed types. Asterisk custom request headers are included. Asterisk access control allow credentials is needed. Before sending the actual request, the browser sends a options request to the server to determine if the cross-origin request is allowed. This options request includes the origin, access control request method, and access control request headers. The server must respond to the options request with the following headers. Asterisk access control allow origin. Asterisk access control allow methods. Asterisk access control allow headers. Asterisk access control max age, optional, for caching. If the server's response indicates that the request is allowed, the browser then sends the actual request. If the server's response indicates that the request is not allowed, the browser blocks the request and generates a CORS error. 4. CORS configuration in Pega. Pega offers several ways to configure CORS, providing flexibility based on your integration needs. Asterisk 1. Using the Pega rules HTTP service ***, recommended for API integrations. This is the most common and flexible method. You create an HTTP service rule in Pega that serves as the API endpoint. Within the HTTP service rule, you can configure the CORS headers dynamically. Asterisk 2. Web.xml configuration, deprecated, but still valid. You can modify the web.xml file of your Pega application server, example Tomcat, WebSphere, JBoss, to configure a global CORS filter. This affects all requests handled by the server. This is generally not recommended because it can be too broad and difficult to manage. Asterisk 3. Custom Java code ***. In rare cases, you might need to write custom Java code to handle CORS headers. This is typically only required for very complex scenarios or when working with legacy systems. Generally avoid unless absolutely necessary. Let's focus on the recommended approach, Pega rules HTTP service configuration. Here's a step-by-step guide. 1. Create an HTTP service rule ***. In Pega Designer Studio, navigate to Records Integration Services HTTP. Click Create. Enter a name for your service, example My API Service. Specify the applies to class. Select the rule set. Click Create and open. 2. Configure the service Service tab define the service name, description, and URL pattern, example /API/mir source. Request tab define request parameters. Response tab define the response format and any data transformations needed. Security tab authentication and authorization configuration. This is important when combined with access control allow credentials, true. Service activity this is the core activity that executes the logic of your service. 3. Implement CORS headers in the service activity This is where you dynamically set the CORS headers based on the origin of the request. Open the service activity you defined in the HTTP service rule and add these steps. Explanation of the Java code tools.getRequester.getRequestHeader, origin. This retrieves the value of the origin header from the incoming HTTP request. Tools.getResponse.setHeader, this sets the value of the specified HTTP header in the response. Whitelist approach the code demonstrates a common and secure approach where you maintain a whitelist of allowed origins. The if origin.equals block checks if the incoming origin is in the whitelist. Only if it is, the access control allow origin header is set to that origin. If origin is dynamically configured in a Pega data object, you can retrieve it with a data page and loop through it and compare it with origin header. Logging and error handling if the origin is not in the whitelist, the code logs a message, important for security auditing, and sets the HTTP status code to 403, forbidden, to indicate that the request is not allowed. This is crucial to prevent unauthorized access. Return false from the activity to stop any further processing. Asterisk credentials asterisk the access control allow credentials header is set to true only if the service requires credentials, example cookies, authorization headers. If you set this to true, you must not use asterisk for access control allow origin. You must specify the exact origin of the request. Asterisk max age asterisk access control max age is set to 3600 seconds, 1 hour, to instruct the browser to cache the pre-flight response, reducing the overhead of future pre-flight requests. Asterisk tools.find string, param.origin.list.property, origin. Here is how you check if the value of the origin header is in a data object or property containing a list of authorized domains. For handle options requests asterisk. Asterisk for requests with HTTP method options, pre-flight requests, your service activity should skip all of your business logic and only set the CORS headers. This is critical. Add this at the start of your service activity. 5. Test your service asterisk. Asterisk use a tool like Postman or a web browser to send cross-origin requests to your Pega service. Asterisk inspect the HTTP headers in both the request and response to verify that the CORS headers are set correctly. Asterisk use your browser's developer tools, network tab, to see if any CORS errors are reported. 5. Practical examples. Example 1, Basic API Integration, GET Request. Let's say you have a Pega application hosted on http://appexample.com that needs to retrieve data from an API hosted on http://api.example.com/data. Asterisk JavaScript code, in http://appexample.com. Asterisk Pega service activity, on http://api.example.com. Example 2, post request with custom headers. Suppose you need to send data to your Pega API with a custom header XAPI key. Asterisk JavaScript code, in http://appexample.com. Asterisk Pega service activity, on http://api.example.com. Example 3, allowing credentials and setting access control allow credentials. If your application needs to pass credentials like cookies or authorization headers in cross-origin requests, you need to configure access control allow credentials, true. Asterisk JavaScript code, in http://appexample.com. Asterisk Pega service activity, on http://api.example.com. Important considerations asterisk. Asterisk when access control allow credentials is true, the access control allow origin must not be set to asterisk. It must be a specific origin. Asterisk the client-side code must also explicitly set credentials, include in the fetch or XML HTTP request configuration. Asterisk authentication and authorization should be handled properly on the server side to ensure that only authorized users can access the resource. 6. Debugging CORS issues. CORS errors can be frustrating to debug. Here are some common techniques. Asterisk browser developer tools asterisk open your browser's developer tools, usually by pressing F12, and navigate to the console or network tab. CORS errors will be displayed in the console, often with helpful information about the missing or incorrect headers. The network tab allows you to inspect the HTTP headers of both the request and the response. Asterisk check HTTP headers asterisk use a tool like Postman or your browser's developer tools to inspect the origin header in the request and the access control allow origin, access control allow methods, and access control allow headers in the response. Make sure they are set correctly. Asterisk verify pre-flight requests asterisk for complex requests, ensure that the browser is sending a pre-flight options request. Verify that the server is responding correctly to the pre-flight request with the required headers. Check the server logs. Examine the logs of your Pega application server to see if there are any errors related to CORS. The logs might provide more detailed information about why a request was blocked. Make sure you are logging when requests are blocked because of CORS. Postman. A tool like Postman is helpful, but it can mask some CORS issues. Postman does not enforce CORS the same way a browser does, so requests that work in Postman might still fail in a browser. However, Postman is still useful for inspecting the headers. Common errors. No access control allow origin header is present on the requested resource. This is the most common error. It means the server is not sending the required access control allow origin header. Response to pre-flight request doesn't pass access control check. The value of the access control allow origin header in the response must not be the wildcard when the request's credentials mode is include ***. This error occurs when you are using credentials include, and the access control allow origin is set to ***. Request header field X custom header is not allowed by access control allow headers in pre-flight response. This error means that you are sending a custom header, example X custom header, that is not allowed by the server in the access control allow headers header. Conflicting headers. Ensure that there are no conflicting CORS headers set in different parts of your application. For example, if you are setting CORS headers in both web.xml and your service activity, they might conflict with each other. 7. Advanced CORS concepts. Wildcards, using access control allow origin, allows any origin to access the resource. While convenient, this should be used with caution because it effectively disables the same origin policy for that resource. Only use it for completely public resources that don't require any authentication or authorization. Never use it when credentials are involved. Dynamic origin handling. For scenarios where you need to allow a dynamic set of origins, example multiple subdomains, you can use server-side logic to determine the allowed origin based on the origin header in the request. This requires more complex code, but it provides greater flexibility. This is demonstrated in the Java code examples above. Pre-flight caching. The access control maxage header specifies the duration, in seconds, that the browser can cache the pre-flight response. A longer maxage value can reduce the number of pre-flight requests, improving performance. However, be mindful of the cache duration, as changes to your CORS configuration might not be reflected immediately in the browser. Vary. Origin header. This header is highly recommended when using dynamic origin handling or access control allow origin. It tells the browser that the server response varies based on the value of the origin header. This prevents the browser from incorrectly caching responses for different origins. Add it to your service activity. 8. Security best practices. Be specific with origins. Avoid using access control allow origin, unless absolutely necessary. Instead, explicitly specify the allowed origins. Validate input. If you are using dynamic origin handling, carefully validate the origin header in the request to prevent malicious origins from being allowed. Use a strict whitelist of allowed origins. Never blindly trust the origin header. Handle credentials carefully. Only set access control allow credentials, true when required, and ensure that your server-side code is properly handling authentication and authorization. Use HTTPS. Always use HTTPS, SSL/TLS, to encrypt communication between the client and the server, especially when handling sensitive data or credentials. Regularly review your core's configuration. Periodically review your core's configuration to ensure that it is still appropriate and secure. Log cores events. Log blocked requests and invalid origins to monitor for potential security issues. Secure your API endpoints. Cores is not a substitute for proper authentication and authorization. Even if you have a permissive cores policy, you should still secure your API endpoints with appropriate authentication mechanisms, example API keys, OAuth 2.0, JWT. Consider CSP, Content Security Policy. While not directly related to cores, CSP is another important security mechanism that can help prevent cross-site scripting, XSS, attacks. CSP allows you to specify the sources from which the browser is allowed to load resources. Conclusion: CORS is an essential security mechanism for building modern web applications that interact with resources from different domains. By understanding how CORS works and following the best practices outlined in this tutorial, you can securely and effectively configure CORS in your Pega applications to enable seamless integrations with external systems and services. Remember to prioritize security and carefully validate all CORS configurations to prevent potential vulnerabilities. Always prefer the Pega Rules HTTP service approach for dynamic configuration and improved security.